Okay, so with L'Hopital, right, we have to have a rational expression. However, there is another type of an indeterminate form. And you're going to learn more in Calc 2 also, but for us right now, we have 0 times infinity or infinity minus infinity. That's an infinity, contrary to what it may look like. All right? So, this one is the one that you're going to use all the time. It just is. Infinity minus infinity, yes, that is an option, but we're not going to use that as much. 0 times infinity, that one's used a lot. A lot. And see what this looks like right here. So here is example 4. I have the limit as x approaches infinity here of x squared times the sine of 1 over 4x squared. I have infinity. I'm approaching infinity. So this is infinity, and then I know my denominator is going to infinity. So the sine of 0 is 0, indeterminate form. All right, so here's the deal and why it is related to L'Hopital. With this indeterminate form, we rewrite the expression to be rational. And why does it have to be rational? So we can use L'Hopital. It has to be rational to be able to do L'Hopital. So if I have something that's set up like this 0 times infinity situation, or infinity times 0, however you want to write that. I mean, it's commutative, right? It's multiplication. We can rewrite this so that we have something that's rational. So how do I take my exponent here and I'm going to move it to the bottom so that it is rational? I'm going to scoot this up a little bit. So I now have my limit as x approaches infinity of the sine of 1 over 4x squared over x to the negative 2. Do you see that? All right. All right, all right. So I could move that back to the top that I'm looking at, right? And it would be the same. That looks like a 9. That's a 4. Okay, so let's see if as x approaches infinity, I'm going to rewrite this just so we can see it better. This is equivalent to the sine of 1 over 4x squared over 1 over x squared. I'm just going to put this right here just so you can see it. Do you see that? Okay, so what happens as x approaches infinity? This is the sine of 0, which is 0, right? And then my denominator of 1 over x squared, as my denominator grows huge, this whole thing goes to what? A 0. Indeterminate form, baby. L'Hopital style. All right, so let's do this. I'm actually going to, just because, 98% of success in mathematics is organization, right? I'm going to rewrite this here a little bit just because it's easier to take a derivative. If I look at this as the sine of 1/4 x to the negative 2 over x to the negative 2. Now talk to me. Why did that 4 stay in the bottom? Yes, so if I'm looking at this, the only thing that goes to the top is what's exactly touching that exponent. That 4 is not touching that exponent. There are no parentheses there. This is like 1/4, 1 over 4 here, and the only thing that has that exponent that I'm moving is that x to the negative 2. That just makes it easier for the chain. That's the only reason why I did that. All right? Now let's L'Hopital, because I know this one is 0 over 0. It's just rewritten. I have my limit as x approaches infinity here. The derivative of the outside, keeping the guts, times the derivative of the inside. And this is where I have, bring that negative 2 in front, I've got this negative 1/2 x to the negative 3, right? Yes, okay. Over here, whenever I have this x to the negative 2, I'm going to have negative 2 x to the -3. Do you see that? Now clean it up. X to the -3 and x to the -3 obviously cancel. Negative divided by a negative is a positive. But what is this? 1/2 divided by 2 is equal to 1/2 times 1/2. Right? So I get a 1/4. Right? I'm just looking at my numbers. 1/2 divided by 2 is going to be 1/4 that I'm looking at. Okay? So now I end up with, scoot it up a little bit. I'm not L'Hopital again. I'm just taking the actual limit. I've already done my L'Hopital. I can write this as, so 1/4. So I'm going to put a 4 in the bottom, right, of cosine of 1/4x squared. As this approaches infinity, I have the cosine of 0. What's a cosine of 0? 1. And then I've got that 4 in the denominator. Cool, right? Indeterminate forms. Indeterminate forms. All right, let's do one more and then we'll call this good. Oh, not on that page. Let's do one more right here. I'm going to call this example awesome, just because when it comes to trig, you guys just need that practice, which is a good thing. I'm going to take the limit as x approaches pi over 2 from the left of x minus pi over 2 tangent of x, right? So let's see what we get here. If I plug in pi over 2, then pi over 2 times pi over 2 is 0, right? Now tangent, if I'm approaching pi over 2 from the left, where am I going? Right, there's negative pi over 2, there's pi over 2, and then here's tangent. What happens, where am I going? Yes, so if this is tangent x, I'm going to infinity because I'm approaching pi over 2 from the left. As I come to pi over 2, I'm going to infinity. Check it out, y'all. There's my indeterminate form. That means I now have to manipulate this into something that is rational. Am I going to go trying to put something like this in the denominator? No. Not when you have reciprocal identities. And that's the other beauty of trig. I am not doing L'Hopital yet. All I'm doing so far is just rewriting my rational expression. So I've got x minus pi over 2 staying on the top, but my tangent moves down below. What's the reciprocal identity of tangent? Cotangent. Yes, it is. Now, let's figure out. I've got a 0 on top, but what's cotangent look like? Oops. I've got this cotangent, and I'm going to change this up because it's on the 0. Is here at 0 and pi. And cotangent is going to swing down like this. So, what is happening? This is pi over 2. That's where it crosses in the center between those two, right? If this is my cotangent of x, what is happening when cotangent is pi over 2? Yeah, it's at 0. So there's my indeterminate form, 0 over 0. Yeah, so now I L'Hopital. The limit as x approaches pi over 2 from the left. So pi over 2, this is just a constant. So the derivative of the top is a 1. The derivative of cotangent is negative cosecant squared. Good. Now, whenever I plug in pi over 2 to cosecant squared, what is cosecant at pi over 2? Right? So this is going to be negative 1 over the sine of x. So negative 1 over 1 whenever I plug in that pi over 2. So then I get that negative 1. Good. So this is going to give me 1 over negative 1, which is a negative 1. Trig doesn't go away, and you guys know I love trig because you're going to have a bunch of it in Calc 2. So anytime I can put it in Calc 1, I'm gonna. Most than anything, it's just remembering, what do these graphs look like? What is this approaching? Just that trig review, right? Just being able to work with it in these different aspects. Cool. L'Hopital. Indeterminate forms. Rational expression. You've got to write your LH. You've got to write this. If you struggled with your limit notation, at the beginning of this course. Get it together now because you got to know it. All right, go rock the socks off of this. You guys can do this.